then that polynomial is said to be interpolating polynomial, and the method applied on this is known as polynomial interpolation. So now today we are going to have the discussion on the assumptions of the interpolations. What are the important assumptions of the interpolation? So as a technique we have seen, this is a technique or this is a method which is used for estimating the dependent variable or the value of the function for given intermediate values of the arguments for the independent variable. This was the technique of the interpolation, and whenever these intermediate values become the values from outside, then the interpolation becomes extrapolation. So we have seen the conditions of the interpolation as well as extrapolation. Extrapolation is also very useful because when we do not have the data outside the range of the intermediate values, then approximation becomes very important. Now the assumptions, what are the basic assumptions before we discuss the interpolation methods or interpolation techniques? One very important assumption is that there should not be any sudden change or jumps in the values of dependent variable for the period under consideration. Suppose we are going to study in between the data from 1981 to 1991, then values of the function, for example, there is a data we take here, 81 to 1991. This is the time period. Time period in the sense that for 81, we have two things. 1981, we start with x1 or x0. We start with data x1, and this is the independent variable, and later we go to y1, or you can start with the x0 and y0. Similarly, we come to the 1982, and we corresponding to this we get x2, and here y2. Similarly, so forth, so on. We come to the 1991, and how many? The 1, 2, and then this will be 10, and I think this will be 11. So corresponding to this time, we are considering two datas. Data set is x1 and y1, ixi and yi. This is the dependent variable, means this is the function, and this is the independent variable. So these are the intermediate values. What is happening here, that assumption, first very assumption, that there should not be any sudden or steep change in the dependent variable. In the dependent variable means y1, y2, y1. Suppose we take this part, the number of wagers or labor. Last example, beginning example. Let us revisit the beginning example. Suppose here x1, x2, xn, and x11, they represent the number of wagers or number of laborers. Here these are representing or showing the costs, means wages. So one is wagers, and another is wages. Do you know wages? Wages means mazduri and wagers means mazdoor. Now condition is this, that these wagers are here, x1, x2, so forth, so on, and wages are y1, y2 and yn11. So these bases means these are the dependent variable or the function or values of the function must not be suddenly changed or steeply changed. Steeply changed means that you have data of this. You have data of this of 1981 to 1991. Okay, and if this is suddenly changed, then interpolation will be wrong. For example, I just say here, suppose I say this is 5, y1 is 100, for example, and say this is 10, this is 10, then this is 1000, and suddenly here x3, suppose here is the x3, here is x3, here is x3, x3 you get 15, but sudden change, you create the sudden change here, y3, this y3, this is 5000. So forth, so on. Now this, what I want to say, if you look at this part, from here to, if you look at this part, I mean to say this part, this is the part where changes are sudden. If changes are sudden, and if you want to interpolate in between 81 to 82, suppose after 6 months, then trend is what? Trend is 500 and 1000. So something you will compute here that will come around the 700 or something. But here, whenever you compute the values in between this y2 and y3 corresponding to x2 and x3, then here will be suddenly very high change. So this interpolation technique would not be serving the purpose of interpolation, and the interpolation will be wrong. The method applied will be wrong. Therefore, there are certain assumptions uh, inevitably which are compulsorily imperative to lay down. So certain assumptions are necessary to be laid down, and therefore assumptions laid down are, the first assumption is there are no sudden jumps or change in the values of dependent variable for the period under consideration. Number one. So first assumption talks about the dependent variable, means the value of the function, not the function. You look at the second assumption, a rate of change of figures from one period to another is uniform. The rate of change of figures from one period to another period is uniform. The rate of change of figures means what? Rate of change of figures. Rate of change of figures, when we talk about the rate of change, is what in the derivative. The first derivative always reflects, always represent the rate of change of figures. So here rate of change of figures means that is reflected by the first derivative. Rate of change of figures means rate of change of y with respect to x. So what we say, the rate of change of y, that this I talk about here time and dependent variable means function. But look at that is not sufficient. Only the first assumption is not sufficient. We need to allocate. We need to lay down some more assumptions, and therefore here the emphasis has been made in the second assumption that the rate of change of figures. Rate of change of figures means y is changing with respect to x, and therefore the rate of change of y with respect to x, that should be uniform. Means that when we talk about the first derivative, but here is not talking about the derivative, that will be the numerical derivative. It is not the exact derivative, and therefore the numerical differentiation is very important. And we talk about the numerical differentiation in place of the exact differentiation. And in your book, the numerical differentiation, they have already completed and they have come to the numerical, this interpolation and difference, concept of the difference, finite difference. But this must be the first chapter, and thereafter, this must be earlier chapter, and thereafter the numerical differentiation. Picture what happened. Hello.
Yes.
Time period and the dependent variable, that is the function. Now second assumption has been laid down, keeping in mind the rate of change of the dependent variable or the function with respect to x. Means in both changes must be uniform. And the first derivative is here very important, but here we are not going to have the first derivative, exact derivative. We cannot talk about the exact derivative dy dx. We cannot talk about the ddxy. ddxy here we can. Here we cannot talk about ddx. We can't talk about ddx. We can't talk about dy dx. In the because this is the exact differentiation. This is the exact differentiation. Exact differentiation. My point is this. So here exact differentiation we cannot talk about, and what we will talk about, this in place of dy dx, we will talk about the numerical differentiation. This is also in your course, I think, numerical differentiation. This is in course. Differentiation. Differences. So these two assumptions are very important when we are going to define the interpolation techniques and going to compute the interpolation techniques, because this is all about the way of approximation, and whenever we are going to estimate or approximate, the computational process will involve. We cannot handle these things manually. The computer softwares, computer machine, the programming languages, the programming environment of various softwares, these will, therefore, these example, whatever examples we are going to discuss now, these are possible to have the calculations or computations manually, but actually in the case of application, the examples, the problems are very, very rigorous and complex, which are very difficult to be handled because the number of iterations increase. Now we come to the concept of difference. Here, if you look at this very point, I just remove all these things. Based on the calculus of finite differences. Calculus of finite differences. Calculus of finite differences is important. Calculus of finite differences. So calculus means what? Calculus. Calculus means calculation or calculation. Calculus means calculation. calculus of calculus. Calculus means so calculus and calculation of differences. Differences of what? Differences of what? Differences of values of the variable according to the differences taking place in the independent variable. So these differences we are going to discuss, and these calculations all together, all sum total of calculations is known as a calculus of finite differences. Talk about the finite differences here. Finite differences because it ranges on the basis of the natural numbers or the positive integers 0, 1, 2, so forth, so on, 3, so forth, so on, en. But here is n is finite because we cannot, unless we make it finite, we cannot go for the calculation. For example, you say the n is equal to 10, it's okay. Possible. Number of iterations are possible. You say number 1000, 100 or 1000. Yes, possible. It is made. It is done with the help of the machine or the computer. 1 lakh, yes, it is possible to be done by the computer. But you cannot say the infinite number of times I want to have the. I mean, you can't say like this that infinity n is equal to infinity number of times calculator, or you allow the machine or computer to make the iterations infinity number of times. No. This is not allowed here. You have to make it a specific. You have to make it finite. Finite, unless you make it finite, infinity is not countable. Infinity is not countable. You remember. Why infinity is not countable? Infinity is for the practical purposes. We are not able to handle the infinity so far. Infinity for the practical purposes, for finite purposes, this is only the very large quantity. Very large quantity. Very large quantity. This is why we can handle this very large quantity, because this is our senses are trained for the large quantity. But large quantity means we need to have the finite quantity. We cannot handle the infinite quantity. Why we cannot have? What are the answer to this question is why we cannot handle? Because the senses are limited. Our senses are limited. Our senses are limited. Limited. Senses means our knowledge senses are limited. Our action senses are limited. Knowledge senses are what? Our knowledge senses. We have the 5 important knowledge senses. Knowledge senses means this: the ear, this has the limited capacity; the eyes, this has the limited capacity; the nose, this has the limited capacity; tongue, this has limited capacity; the skin, this has limited capacity. So senses, that is controlled by the mind. Mind is also, its power is unlimited, but we cannot handle the power of the mind as unlimited. It is limited. Only 5% or 2% or 3% we are using the power of the mind. So if we can increase the power of the mind, so we can, perhaps in the future, we can handle the infinity. But here you have to make it finite, and therefore this very word is very important here. The finite differences. We talk about the finite differences. Keep in the mind the finite differences. We are going to have the calculus of the finite differences. Earlier we had the calculus, the differentiation, integration, that is also known as a calculus. But that time we say only the calculus. Is calculus your part? You say very simply, you answer, yes, sir, I study calculus. But after the calculus, you make no any uh, qualification. You make no any other significance like calculus of anything. No, you say simply calculus, because everything is understood in that, because the variable was there, the computation was there, the based on the continuous variable. There was integration, there was I mean this differentiation, but here everything is calculus of finite differences. That difference, in case of the calculus, we talk about the another calculus, the calculus which we have already studied. That calculus is what? Calculus based on the infinitesimally small differences. Look at here. That is the case of finite difference here. But in case of calculus, what happens? In case of the calculus, in difference is what? Difference is infinitesimally small. That is important here. This is the great philosophy, the philosophy of great length and breadth. Infinitesimally small differences. And therefore, we are able to take here integration. Otherwise, we cannot integrate. Only we can sum. But here, we are not going to integrate anything. You will surprise here. Everything will be based on the numerical integration. But here, not the difference is infinitesimally small. This is the important in case of the calculus. But here it is this is the calculus of the finite difference. Therefore, its name is very, very popular. Never forget, when you are shifting the concept from calculus to the calculus of the finite difference, but calculus of the infinitesimally small difference, infinitesimally small difference is never, ever is spoken with the calculus, because this is very much understood. Okay, let us come and talk about this. What is this difference? This difference is, I remove this all these things. So you got my point. And several kinds. These differences are several types. Differences of and in the forward difference, we will talk about the forward difference. We will talk about the backward difference, and we will talk about the central difference. So how many types of differences, finite differences? We will talk about three types of finite differences. We will talk about. The first is the forward, second is the backward, and third is the central. So here it has been kept in the mind, it has been taken into consideration, this idea that there must be central also, from center to forward, from center to backward. So here is also uniformity in the calculation of the differences. What kind of things we will handle here by the nomenclature? I mean, this may be in your course. You can check it. Newton's binomial expansion formula for equal intervals, and Newton's forward interpolation formula for equal intervals, Newton's backward interpolation formula for equal intervals. So Newton's has given both forward and backward both. One is exceptionally introduced as Newton's binomial expansion formula for equal intervals. I think this may not be part of your course outline. Lagrange's formula for unequal intervals. So that was the special, the privileged contribution to the finite differences, because here this difference is going to be unequal interval on the basis of unequal interval. Lagrange's formula for inverse interpolation, that was also a special contribution. and notable contributions, seminal contributions, we can say, by the Lagrange, who has given the inverse interpolation, and Gauss, the forward interpolation, and the Gauss backward interpolation, the Wessel's formula, Stirling's formula, and Laplace Everett's formula. So these are the, formulas or formulae which we can study. The plural of formula is formulae, and we also speak and we also allow the formulas. So either you speak formulas or formulae, both are correct. Finite differences operator. I begin with the finite difference operator. Consider a function. Here we are going to consider a function fx defined on AB. The domain is the AB. Here this has printing error. Printing error. Here this would be a comma. Consider a function fx defined on this. This is a comma, not full stop. X and y are the independent and dependent variables, so respectively. The points x not x1, x2, so far so on xn are taken at eq distance. Remember this, note this very point. The differences are eq distant, means xi is equal to x0 plus ih. I is ranging from 0, 1 to so forth, so on. I mean, if we talk about the difference here, if it is, if it is this xi is equal to, here written x naught plus ih. This is important. I is ranging from what? The 0, 1 and 2, etc. So if it is ranging, then what will happen here? When we talk about the x naught, I is equal to naught, then x naught is equal to x naught. X naught is equal to x naught because I is equal to 0. So h factor is 0. When we talk about the x1 will happen what? x1 will take place x naught plus h. This is eq distant because the x2 is equal to what? X naught is fixed. X naught is fixed plus
2h.
Yes, correct. 2h. Next will be 3h. Next will be 4h. So on. So this is IH. So this is how beautifully we have defined the equidistant with the help of the H. And this is we are going to handle here the equidistant or unequidistant. Only two ways of calculating the difference, equal and unequal. So here I is not going to be allowed. I is always integer here, 0, 1, 2 like this. You say the fractional value or real values not allowed. This will become a case of continuity, a continuous random variable, and this again becomes the case of what? This will become the case of the calculus, not the case of what we are studying here. We are studying here the calculus of finite difference. So whole thing is the calculus of finite difference. When we are unable to solve the exact differentiation, exact integration, exact differential equation, everything becomes the numerical based on the finite difference. Means numerical integration, numerical differentiation, numerical differential equation, and so forth, so on. So I think then what we are going to say, then the value of y and x is equal to xi, they have made it general. I mean particular yi is equal to fxi. I think you are looking. Yeah, this one is important. It has been made for I. This is a specific. The values of x are called arguments. Values of this is arguments. I have already told you arguments and entries. The same thing I have encountered here in this chapter. The values of y are known as entries. Entries. The interval h is called the difference interval or differencing interval. Difference interval or the interval of differencing. Both are popular. Difference interval or interval of differencing. Both are popular. And the all differences. The first difference is what? y1 minus y0. y2 minus y1. yn minus yn minus 1. These are differences of the function or dependent variable are called the first differences of the function y. They are denoted by delta y0, delta y1, delta so forth, so on. This delta is a capital delta or big delta. We are also going to have the notation of the smaller delta. So first difference is important, and first very difference is delta y0 is equal to y1 minus y0, delta y1 is equal to y2 minus y0, y1, and so forth on. yn, delta yn means yn minus yn minus 1. This is called the difference operator. This is called. So delta here is one operator. This is the difference operator. This is popularly known as forward difference operator. This is a forward difference operator. This is forward.
यहाँ पर डेल्टा वाई एन को तो वाई एन प्लस 1 माइनस वाई एन होना चाहिए.
हाँ, बोलिए.
डेल्टा वाई एन को वाई एन प्लस 1 माइनस वाई एन.
Here will be what? The
y4 minus y3.
Yes, minus y3. So last whatever you say here is talking about. I mean this part. This one is greater, and this corresponds with this. What he is saying, delta yn is talking about the yn, delta yn. So here you say here n. Okay.
Yes.
This is your question.
Yes sir, वो यही कह रहा था कि yn plus 1 minus yn होना चाहिए.
And yn. Okay, n plus 1. But you are starting from here 0 to n.
Yes sir.
Yes.
तो इसमें n plus 1 नहीं होगा.
Exactly. Then they have symbolized only. If you say here, so you put here n minus 1.
Yes sir.
That n minus 1, and then 1 minus.
Then yn is equal to, yeah.
So n minus 1 0 to n, and if n plus 1, if you put here n yn, then you have to put here n plus 1.
Okay sir.
Okay. Now in the example this will be clear. So you keep in the mind, if 0 is here, then 0 is here. This is a smaller quantity. If y1 is here, the right hand side 1 is here. This will be difference will be calculated from y2. Okay, so this is the one important point is also here. The x0 is the beginning. It is starting with the x0. X 0 or 0 argument. This is a hero argument, or this is hero term is not adopted by the mathematics. It is general term when nature is heroic, when anything is started from any item or any person, that becomes hero. Nowadays, just like doctors have become hero in this society nowadays, nursing staff and other things. Now, so this is popularly known as leading arguments. Leading arguments. This is known as leading argument. So this argument is very prominent argument, and therefore this is the leading argument, and therefore this difference, this very difference. I'm talking about this difference. This difference in which y naught is involved. If y naught is involved, means x naught will be involved. X naught will be involved. This difference is known as a leading difference. Leading argument, then this will be leading difference. This is known as the leading difference. Okay. Now we come to the forward differences. Forward difference. So forward difference is what? The forward, another is backward, another is central. Okay. So all three possibilities we are given. Now we are discussing here the first one, that is the forward. We move forward. This difference is what? The forward difference or simply difference. Operator is denoted by delta, as we have seen, may be defined as delta f is equal to f of x plus h minus x. Or writing in terms of the y at x is equal to xi, question 5.2 becomes for the I, when xi becomes xi, this is a particular case, with the suffix I, since delta fxi is equal to fxi plus fxi. I think there is no problem here. Okay. And delta yi is equal to delta I plus 1 minus y. Delta I. Here you look at here. Your problem is coming into picture. You look at here, I is ranging from n minus 1. Here they have defined I is ranging from 0, 1 to n minus 1. Since in that very case they have already defined up to n, therefore they are going up to n. But they had problem of convincing the people that how they have made it. But here it is allowed. I plus 1 means I plus 1 means here plus 1 means n. If you add 1, this is equal to n. Then it becomes equal to n. So differences of the first difference are called the second difference. The first difference is this one. And differences of the further differences, I mean this second difference. We look at here second difference. Second difference is what? The first delta y1 minus delta y1. Our first difference means order. First means not the first time. The first time is not first order. So delta y1 is bigger quantity. Okay. And delta y1 is smaller quantity. And this is delta y1 is this. And delta y2 is this, and y1. And simply you come to this point, y2 minus 2 y1 plus y2. Now blindly closing your eyes, you can do all values. Delta square y1. Here y1, so you increase one value. This will be y3, minus is minus, 2 is 2, increase one value. This will be 2, increase one value. This will be 1. And similarly, delta cube delta 2 y2, this will be y4 minus 2 y3, plus this will be y2. And delta square y4, so for this one you can compute without making a lot of very serious effort. We can compute this. Now this is third order difference. Second difference, this was second, this was first. No, this was first. Now the first, this was second, this was third. Third is what? Delta square y1 minus delta square y0. Delta square y1 is what? Delta square y1 is this, and delta square y0 is this. You make the difference of these two quantities, this quantity. So difference, this is this, already this, and you are getting y3 minus 3y2 plus 3y1 minus y0. Similarly, you can get by closing your eye without making any serious efforts. You can make it. You look at here y4, this has become y4, 3 has become 3 minus 3, this will come, y2 has become y3, and y1 has become y2, this quantity plus not going to be changed, and y1, this way this has been generalized. A general formula y delta yn plus 1 fx is equal to delta n fx, same thing, and ultimately they have written n is equal to in this way. Delta n plus 1 fx, here you look at the difference. Delta n plus 1 fx and the delta n and the fx and delta n fx plus h and delta n. So
सर यहाँ पर जैसे जो
Yes,
that is the problem here. They have computed only two values here, delta square y0 and delta square y1. Similarly, we can compute here delta square y2, delta square y3, delta square y4, delta square y5, delta so forth. Similarly, we can compute here delta cube y0, delta cube y1, delta cube y2, delta cube y3, y4, like this. Only two values are computed here because they have used only two values. But I already told you this book is full of errors. The writing pattern the professor has not revised, has not checked. He had only the he was in hurry in publishing this book. Here basically they must write after this dot. Do you get me or not? After this
Yes.
dot, or so on.
Yes, sir.
Yes.
So is it clear or not? Why Sunesh?
हो गया सर,
हाँ
क्लियर हो गया सर.
हाँ क्लियर हो गया. चलिए अब दूसरी कोई बुक निकालिए, उससे पढ़ाएं, इसमें प्रॉब्लम. This are coming to the forward difference. This is. Let us take the example. Now this is the theory, central difference. This is central difference. Now come to the one example of the forward example. Come to the central difference, and where is forward difference? Okay, they have given this table. I have not shown. So this table is okay. Now this way of writing is okay. I think there is no problem here. Yes, this e power 0. This is the difference. This is not power. This is difference. So therefore, this is equal to not. You keep in mind these three signs are here. This is identity operator. This is IO. and IO affects the function like this. Means it does not affect. It makes no difference. Means fx remains indifferent by operation of identity operator. This is not equal to 1 or something. Mathematically, we start computing this. But whereas lambda 1, first difference, is simply written the delta. Keep in the mind. So we calculate the difference here, whatever we did here. How many entries or how many arguments? 5. No, including 6. Including this is 6. How many entries? 6. Up to 5. It ranges up to 5. N is equal to 5. N is ranging up to 5, but entries are 6. So first difference, delta y0, delta y1, delta y2, delta y3, delta y4. So the first difference will be up to y4 n minus 1. Here n is 5, so n minus first difference. Second difference, y0, y1, y2, y3. Second difference is less than by 2. That is only 3. Here is only 2. Here is only 4. This is 5. So next is only y2. These are the third difference. And the fourth difference only up to 1, less by 4. That is 5 minus 4 is 1. And fourth and last difference is 5. 5 is delta 5 y0. This is the last difference. Means if you subtract from n minus n is equal to 0. So only this remains. So this is a table which will be used in our numerical. Now I come to the more this line, they say this line. This line, they say this line, this difference, y not involving y not involving y not. This diagonal line, differences for the arguments x naught, these are shown in table, no problem, called diagonal difference. Definitely they are diagonal difference table. That first item in table, this y naught is called the leading term. I have already explained this leading.
सर y नॉट नहीं होगा x नॉट होगा.
Huh?
अच्छा sorry.
First table, the, y naught is called the leading term. Here is the leading term. That was the argument, leading argument. The difference on the basis of the legal arguments, leading arguments, this is the leading term. So differences this. Now you look at the differences. These are called the leading differences. So leading arguments, the leading terms, and leading differences. Keep in the mind. Similarly, the differences with fixed subscript are called forward differences. Fixed means 1, 1, 1, 2, 2, 2, 3, 3, 3, and 4. These are called the forward differences. So in this way, we can take one example, and then at least we can finish the forward differences. The polynomial, what happened? Example is here, x arguments are 1, 2, 3, 4, 5. Simple arguments. The function is the 4, the 13, okay, and 34, 73, and 136. This name of the function is, table is given, function is not given, because the function we can keep the function. Only table is given, like this. Forward, which one? 124. 2 leads to 6. I mean the y, and 3 9, and 4 this 12, and these are the entries. These are the arguments. The difference you look at here. The first difference is what? Delta effects. Delta effects is what? Delta y naught. Y naught means delta y naught.
6 minus
y1 minus
y1 minus y0.
Here naught is not given.
4.
So naught is not given. It is starting directly from 1.
yes.
So
y2 minus
here
y1.
delta y1. Okay. Delta
Yes, sir.
y1 is
4.
y minus y1. Y2 is this, y1 is this. So
y2 minus y1.
this is 2.
Yes, sir. y2 minus y1.
Okay. Delta y2. Delta y2.
y3 minus
y2.
Yes. y3 minus y2. Similarly, y4 minus y3. Similarly, y5 minus y4.
y4.
So the first order difference is calculated here. The first difference is not first order. First difference is calculated.
Yes.
Second, delta is square y1. Delta is square y1. The formula. Delta is square y1.
Delta y2 minus delta y1.
Delta
y2 minus delta.
Yes, this is delta y2 minus this is delta y1. So difference is 1.
1.
Similarly, difference 3 minus 3 is 0. Similarly, difference 5 3 is 2. Delta 3 y1.
delta y1 minus net सर यहाँ माइनस आना चाहिए सर होना चाहिए
माइनस कहाँ से आएगा? हाउ यू आर सेइंग?
ये सर ये जब जीरो
फार्मूला
तो सर ये
डेल्टा क्यूब y1 is equal to delta square y2 minus delta square y1.
Yes, sir.
So 0 minus 1 is equal to minus 1. Here minus 1. 2
Yes,
minus
sir.
0 is
yes sir माइनस होगा
okay.
Yes,
And
sir.
delta 4y1 is what? By formula. Here y1 is equal to 5. Then how much differences will go up to 4? Fourth column, if you are getting fifth column, sixth column, your calculation is going to be incorrect. So this formula is y4 y1. y4 y1 is y3 y2 minus y3 y1. 2 minus of minus 1 is equal to 3. Answer, he has given this column correct, but
Yes,
here the
sir.
column is wrong.
yes sir
Okay. Yes. So minus, this is minus. You can correct your book.
yes
So
sir minus
today I wind up my lecture. If you have any query, you can. Otherwise, we can stop it. Open all the, unmute all the audio system.